Hello! Oh, I started the presentation already. Hello, my name is Kristoff Finley, and today I'm going to be talking about blockchain. I'm going to go in depth on the specifics of blockchain. I'm going to give an overview. I'm going to describe things that I found interesting. I'm going to provide examples in the real world. Then I'm going to conclude by asking questions and kind of prompting you to maybe do your own research in the future. But here's the blockchain presented by me. Awesome. So let's start with an introduction. What is it? What is the blockchain? This is a term you hear in the media. This is a term you hear your friends talk about with NFTs and all that type of stuff. But essentially what the blockchain is it consists of blocks, aptly named. Blocks are things that are connected to each other and they contain some sort of information, right? There's a sense of chronology in the sense that each block knows and is connected with the block before it and the block after it via some time. Right? So anytime you have a new block in your system, that means there's new information. That means something else happened. That's why it's often referred to as the ledger, because everything is written down, or in the sense of blocks, is you have more and more new blocks. Moving on, I want to talk about why this is important to cybersecurity. And there's a couple keywords here. One is trust. Trust in transactions. Reese actually talked today in class of how normally you want to provide the minimal amount of trust possible when you want to design a system. Well, in this case, trust is written all over, as I'll explain later, with things such as the consensus mechanism, which you notice in the third point. It's also very hard to tamper with because everybody can see all of the changes. And quickly to talk about consensus, I'll go more in depth in the kind of the bulk part of this video, is everybody needs to agree with everyone at every point in time. And if that's not the case, they know something's wrong. So it's very hard to tweak something without everybody else noticing. Meaning there's this removal of the middleman or this decentralization. No one is in charge of the blockchain. Everybody is, if that makes sense. I'll go into more detail. So now that I kind of gave you an introduction to blockchain, I want to talk about its background. What it is, what it's made of, where it came from, all these types of things. So the blockchain. I have a formal definition for you. This is from IBM's blockchain introduction website. It says, blockchain is a shared, immutable ledger that facilitates the process of recording transactions and tracking assets in a business network. The key word I want you to look at here is assets. The process of recording transactions and tracking assets in a business network. So what is an asset? Well, an asset is anything of value. All right, and you can think of it in two different categories. One category is tangible. This is in the case of a house, car, hard cash, land, something that you can hold, something that you can see. Or it could be intangible, something a little bit more invisible or perhaps intellectual. Examples include intellectual property, patents, branding, copyright. Not something that you can necessarily hold, but something you can assign ownership to. That's what an asset is, and assets build the blockchain. That's what people hold on to. An example of assets working with the blockchain that a lot of people have heard about and is cryptocurrency, and specifically Bitcoin. Bitcoin is the most popular form of cryptocurrency, and I actually went on this website called Investopedia. I'll link the presentation in the description if you want to click any of the links. Everything should be clickable, so you can follow the sources and everything like that. But basically, I took some quotes. It removes the need for a third-party involvement. It verifies transaction, and it is created, distributed, traded, and stored when using its decentralized ledger system known as a blockchain. So something I want to mention here is how blockchain is powering Bitcoin. Bitcoin isn't blockchain, but it uses blockchain as its engine. So a good example that I read or watched a video of is you can think of an engine. An engine can be used in a car, but it can also be used in the Titanic, right? It's the thing that's driving that application. So in this case, the blockchain is the underlying technology to Bitcoin, and Bitcoin is obviously built on top of that, as we'll discuss later. So now that I've given you an introduction into kind of the basic concepts of what the blockchain is made of, I want to talk about the core systems that make it work. And I'm going to start with cryptography. So we actually talk about this a lot in class, and this is something that's in active development right now in 2022. This is something that's not figured out yet. We're still kind of iterating on it, and the main use cases of this is to protect users' privacy and transactions, and it's to ensure data consistency. In class, we talked about asymmetric encryption and symmetric encryption, and they're both used here. I have some graphics to show you that illustrate this point. So for here, for symmetric encryption, the most important thing here is that there's one key. Right? There's this secret key that's used both for encryption and decryption of a message, and then the big difference between symmetric and asymmetric is that there's a secret key that user 1 has, and there's a secret key that user B has. And based on prime numbers and mathematical reasoning and correlation, these secret keys are paired with each other. and they work very specifically together, and they're able to encrypt and decrypt perfectly. So these are the two major forms that are used in cryptography for the blockchain, and I thought it was pretty cool that we studied this in our class, and you were able to see it in the real world. Awesome. The next big system I want to talk about, which you've heard me say these words, is decentralization. Again, another formal definition is it's the transfer of control and decision making from a centralized entity to a distributed network. We're trying to move away from the system where banks are in charge of everything, where you have to talk to somebody else to really do what you want to do. In this case, this is decentralized, or that central entity, it's not there. This makes transactions a lot more seamless. So you have a trustless environment. You have to trust less people, which might sound like a bad thing, but the less people you have to trust, the less things that can go wrong. This improves data reconciliation because it's easier to make transactions. It reduces points of weaknesses because you don't have people who are flaky or who lie. Again, you don't have to put trust in as many people or organizations. And it also optimizes resource distribution because you understand when it optimizes resource distribution as well because you don't have to verify when a transaction happens, and you don't have to wait for people. Everything is a lot faster. Awesome. And I got this from Amazon's blockchain introduction as well. Just trying to get a variety of sources. The last system I want to talk about is consensus. And the definition of this is all periods of the blockchain network reach a common agreement about the present data of the distributed ledger. So this common agreement, I've bolded there, that's really important. And there's a couple of components that go into this. Usually there's some sort of objective, such as coming to an agreement. There's collaboration between the nodes, cooperation, meaning everybody generally wants the same thing. There's equal rights to every node, meaning every node can do the same thing, and there's mandatory participation of every node. This means that no node can be flaky. Everybody needs to be in it together or else no one's in it. And there's a lot of different forms of consensus, and I'll talk about those now. So, consensus algorithms. I have them all listed here that I found. These were all on that same Geeks for Geeks source. One of them is called proof of work. You see this most commonly in Bitcoin. That's where it came by. And they use complex mathematical puzzles to determine who gets to mine the next Bitcoin. One of them, which is a really cool name, is the practical Byzantine fault tolerance, and this is where you reach a consensus with nodes, and you can do so even if they fail or some of the information is not correct, which I thought is really awesome. Kind of reminded me of doing multi-threading on a computer and having all the threads talking to each other even if one fails, which I think is really cool. Obviously very complicated. Another is proof of stake. Ethereum uses this. This has to do with this idea of staking, betting, and also incentives. One of them is proof of burn, which is pretty metal. You basically send these coins to irretrievable addresses. One of them is proof of capacity. So instead of investing in graphics cards, which is what proof of work is, people said, why don't we invest in storage because it's cheaper and more efficient? So that's when you invest in hardware space, like a hard drive, for example. And the last one is proof of elapsed time. This is the fairest consensus because it gives equal share for everybody who wants to get involved. Is there an equal chance to get the next coin? Whereas proof of work and proof of capacity is very kind of buy to win in a sense, because if you have the best graphics cards, you have a whole warehouse of them, then obviously you're going to be able to solve those problems faster. So proof of elapsed time kind of evens the playing field in that regard. Awesome. So now that I've talked about the systems, I just want to give a brief conclusion, and I'm going to do so by asking a couple questions. This really opened my eyes to considering what is money, right? Money used to be bartering goods. We then this is a very brief overview, but we then transitioned to coins, and now I carry around dollar bills in my wallet, or I used to. Now there's cards. Some people even use their phones to tap, right? Well, this idea of money do we need to have borders surrounding money, right? Can't this be an idea of where everybody has the same form of currency, and we do so not by using hard cash or material goods, but by having these digital assets? It's really interesting food for thought. And then this idea of what does it mean to own something, specifically things that aren't tangible, such as brands, right? Such as pictures on the internet, right? I think it could be a really useful case for someone like an artist, for example, who wants to sell their work online but doesn't want somebody to take it as their own, right? Because it's their work. They want to put their name on it, kind of like their watermark, if you will. I want to talk about, or something I think was very topical nowadays, and is the future of the discussion, is blockchain ethical? Especially mining Bitcoin, for example. This uses an insane amount of power, and it can hurt the environment, right, when we're using more energy. And does this really even need to exist in the first place? I don't know. It's something to think about. And is this too complicated? I think one of the draws to money is we've been doing it for thousands of years. Everybody knows that this is worth that much, and carrying money around just kind of makes sense. The blockchain, as I've discussed, is a lot of different moving components, and I worry that it might be too complicated for everybody. These are the sources I used among the other ones I linked on the slides. Again, you can see all these sources in the description. Thank you so much for watching this. I hope you have an amazing day, and this has been Kristoff Finley with Blockchain. Thank you.